I request everyone to please join me in welcoming the moderator with all our panelists.
So this panel is going to discuss about AI, data, and autonomous mobility capabilities. The AI is the most favorite topic nowadays, almost all the industries, especially for automotive is more than favorite, it is more important, connected with our safety, security, and as well as the experience. Okay. So before getting into the topic of AI data, so I would like to start a little bit background, the evolution of vehicles. So if you see that once upon a time, the vehicle was more of the mechanical engine to transfer or to move from one place to another place. Okay, that's how it was started nearly 60, 70 years back. Then slowly the electrical and electronics came into the picture. A lot of ECUs are coming into the pictures. Then the softwares are started growing, and now we evolved and then came into the place called the software-defined vehicles. Okay, so what is a software-defined vehicle? So it is basically, or it is fundamentally run by the three forces: okay, AI, data, and connectivity. So what is AI? AI is not a feature here. So the AI is the experience. AI is the essential for the vehicles. So nowadays we see mobiles, a lot of mobiles in hand, and then we are communicating with the people the moment we think. Okay, same we are expecting everywhere in our home or our office or in the restaurant or even in the car. Okay, so this was the experience. So this experience we want to connect it everywhere. So how this experience are possible with AI? So one of the second force is driving the AI is the data. So the data is the second most important fuel in addition to the either electric or IC engines. So the data is the fuel for the vehicles. So how data is coming from the different sensors like radar, camera, LiDAR, ultrasonic, okay. And then not only the one sensor, throughout the car is surrounded by multiple sensors, so much of data being generated. So human has only two eyes, but whereas the car has multiple eyes in all 360 directions. So if you take a typical car is seeing or observing the environment more than any normal human being. So anytime, all directions. Okay. Then third force, what the SDV is doing is the autonomous capabilities. So it is not only the decision making, it is also giving the experience, right? Then predictive maintenance, and then customized experience, and then decision making, etc. So these three central forces are driving SDV vehicles: AI, data, and autonomous capabilities and decision making. So from the morning we have seen the several topic being discussed with the multiple panel members from different organizations, the regulation, OTA, then the challenges, etc. So this particular topic is a bit more new as well as advanced and also emerging in our automotive domain. So this will be more interesting going to discuss with our panels. What are the challenges and then opportunities in this domain. So say that we'll have a kind of a two segments. So in the very first segments, we'll discuss more on kind of the challenges. Okay, what are the current challenges we are facing in all these three pillars? And then second segment, we will be having a detailed discussion of, okay, how we are going to address these challenges and what are the future and how we are going to drive forward or way forward altogether. So this is a context being set with this context. So I would like to move on with our panelist to start with more on the very first pillar, the AI. So I'd like to ask Karthiga to start with, okay, at being the one of the premier OEM Mercedes. So how do you really see the AI models are scaled for the real-time performance in engine? So we know that the experience, we talked about all, the experience is not something, okay, I give or wish something, it will come next 1 hour or next 1 day. So it has to happen in milliseconds or microseconds. So can you please elaborate on that, how the real-time AI models were scaling it, putting it in the platforms and then bringing it up reality?
Yeah. So the question is about how to scale AI systems for real-time processing, right? So real-time processing in vehicle, right? When we take about real-time processing, I can think of 4 different factors that caters to it. One is it should be fast. Of course, you know, if you're on a vehicle and then there's a lane change that has to be done or a pedestrian that's crossing, your decisions have to be fast enough, right? And then, of course, it has to be efficient because when you have it in a vehicle, you cannot run enough compute and GPUs just like you're doing in a training. You have limited power, limited compute, limited memory. So your AI system really should be efficient enough. And of course, being in a car, it has to be reliable, right? I mean, you cannot always depend on a network connectivity. There can be areas, rural areas where there can be network outages. You can be in tunnels where the car has to take decisions, but it doesn't have the network to do it. So you have to have a fault tolerant system. And also, it has to be a deployable system. You are planning to deploy the software across a fleet of vehicles. All right. The AI system should be in a format that is deployable and it can be updated across a fleet. So now answering the first part of your question about AI systems, right? So the way I think of AI systems is there are 3 parts to it. You design it properly and then train it, and then of course the deployment parts of it, right? When you design about it, there's again the design involves a hardware and a software element, right? The hardware also has to be like more of a parallel processing unit, such that it's not like compute hungry, but we are looking at more of a smaller TPU or neural processing unit or an NPU, you know, which can do good parallel processing, but in a very faster way with a very less compute. So if you can think about AI model, right? AI model basically is more like a, has to be done to hardware. Right? When it comes to software and deploying an AI system in terms of software, so what I can think of is when you build an AI model, you have to build it in a way that it applies to a cross-platform situation. It can apply to an ARM or an x86 or a TPU, right? So that's how it has to be designed, and it also has to be in a universal format, like an ONNX format, you know, that can be deployed across many hardware designs. Now comes to the training parts of it. The training is completely dependent on data. Data, as we know, is from different sensors, and then the more the diverse data that you have, your model is really going to be accurate. That's one other thing, and not just about real life data, but also data that can be simulated. Say you cannot have real life data for hazardous conditions, right? If you can use simulation platforms to simulate those data and then feed it into the model, so that's where you get the highest level of accuracy. And the final thing comes to the deployment. Right? The deployment again is enabled by CI/CD pipelines, by OTA, and then you also have these types of deployments where it can be a canary deployment or you roll out. But when you also deploy, you also have to plan for a feedback system. Right? Your car is on the road, your AI system doesn't work, so you can always have a rule-based system, you know, as a backup, so that things fail. There's also a default, a safety condition that's taken care of. Now the problem is with having an AI system or a model is that, you know, model tends to degrade. You know, you feed in a new data, the model doesn't know what to do, right? So there's always a way of implementing a monitoring or a telemetry system that can also monitor your inference metrics, like how does the model perform, is it reacting in the right way, and all those metrics also has to be looped back in, you know, fed to cloud and given back to the car. So designing an AI system or scaling an AI system for a real-time processing in vehicle is not as easy as it sounds because of the diverse conditions that's there in an ADAS system. But then, all these are the improvements or techniques that we currently use and should be using to design a car.
Hello. Yeah. Thank you for setting up the context. So how critical, and then it's not a one-time job too easy. So we are talking about the AI being the experience. Okay. So with this context, maybe I'd like to go to the Sriram. So how do you see the adaptation of these foundation models in automotive, and also how critical it is, and then when it comes to the customer experience, so what are the consideration we need to do that to bring the experience, and not only the one time, and so the experience is a continuous every day, every time when I enter to the car, I'm expecting the new So from the ThoughtWorks, how you really handle such challenges? Can you please explain to the audience this?
Sure, Thiyagarajan. First things first, good to be here. My first observation was, Sudhanshu also relates, it was good to be sandwiched between OEMs and Tier 1s. But when I saw the table setup, maybe because we advocate a lot of shift left, we were shifted left. Yeah. But your question, Thiyagarajan, I think I see this in two dimensions. Especially in the context of software-defined vehicle, these two dimensions matter the most. One is customer expectations or the experience. The second one is technology. So now when I think of customer expectations, obviously today's user or consumer wants many things or everything in a car. But when we restrict it into a autonomous vehicle, I think the single most, if we'll have to, circle on one single most requirement, that's safety. So if you keep this one dimension and then see the evolution of technology as a dimension. Not many months ago, my desktop had a particular group tab. Today, there are a set of tabs which I have now grouped it and I called SJ_AI. Right, and when I open it up, it has Perplexity, it has Anthropic, it has Gemini, so on and so forth. Maybe many of you have it in your apps and I use it for different purposes. So similarly, when we now think of foundation models to cater to safety requirements, it's going to be very clear that foundation models which will bring in domain capabilities, right, is going to be very, very important, because OEMs and Tier 1s will not be able to, again on my humble perspective, build their own models, or at least it might be not efficient enough that automakers themselves reinvent their wheel. Right, so it would make better sense to work with foundation models which have these domain capabilities baked in and try them out. But unlike me just opening our desktop and deciding on which to use, it's not that straightforward for automotive, because definitely yes, it's a mission critical system. But there are ways now how you can use these foundation models, and today technology companies give you that advantage where you can probably contract a couple of GPUs, use AI research techniques to test them with your own data, with your own models, because I'm sure a lot of automakers would definitely claim, and that's definitely the truth, that they have a lot of domain knowledge which is unparalleled. So making best use of these two worlds to deliver safety, I guess, would be the way forward in how you can deliver that experience and use foundation models to our advantage.
Sriram and Karthiga. So I think we have heard from you that the model training and the deployment and then continuous adaptation. Okay, but how it is possible? It is not possible without the hardware. So, and the hardware is not the simple evaluation board or something. So we need the GPUs, TPUs. Okay. So with this, okay, I want to get the view from Magnus. So what is the role of the specialized hardware accelerators play in, especially on the AI? Specialization experience. Could you please share your experience and then the futuristic view? So how are the hardware accelerators are really handling such a complexities and also the continuous adaptation of AI models?
All right. Thank you. I will do that. First of all, thank you for having me here, and also I would like to introduce Cortura then, because I don't think more than 2 people in here know what this company is. Because those are both from Daimler and Volvo that I've met here. So we're a joint venture created by Daimler Trucks and Volvo Group to develop and deliver software-defined vehicle platforms. And that is hardware-based software, middleware, and APIs. And then applications will be done by the competitors. So that's us. And when I hear your question there, hardware accelerators, I think we're 5 up here, so probably 5 different opinions what an hardware accelerator is. But for me, it's everything that kind of offloads the CPU. And we need to do that. We need to do that already, but it's accelerating. And we need to do that because we need, in some areas, faster decisions than a CPU can do. And in others, CPU or compute that all equals heat. And we need more efficient ways of computing than CPUs only, because even though trucks seem big, they are big, but they're not big when it comes to packaging HPCs in them. So heat is actually one of our major problems. Technology has all the socks available for us to use, but we can't use them fully because then we would be running too hot. So experience-wise from trucks, we've of course seen some accelerators already. We have the GPUs and the DSPs already integrated in the socks in our, let's say, in our IVI systems and so on. We use a little bit of that when it comes to ADAS, but that not so much in the lower levels yet because we have smart sensors so far. But there we see that the smart sensors are going out in the next couple of years, and then we will go to raw sensors, which means that we will do all the compute that all the autonomous companies does. We will end up in a similar situation on a regular truck, which is, you've all seen the orange or whatever NVIDIA has these days. And if we need to put one of those in each truck, that's going to be an issue for sure. But that's where we are right now. What's also happening is that we see LLMs finding their way into everything these days, not only in that area of ADAS or IVI. It's not just a voice assistant anymore, not just something that changes your music or raises your temperature. It's the trucks now need to understand what you want, and they need to understand how you want to solve it. So one of the favorite examples I have is from when I was in the Bay Area last year, where I could drive a truck, and I went up to a stop sign, and I told the truck that I don't see the stop sign. And then the LLM needs to then understand what my problem is, but it also needs to understand, okay, how do I solve it? So it then started tracking the adaptive lights with their front cameras. And for all of you who are in the architecture, those are usually different domains and zones. So all that communication tracking, and then within half a second or so, lighting up the stop sign and solving my problem. And it could be the same if I feel like my ride is too rough. It needs to understand how to fix it. Not only that I want it softer or harder, it needs to fix my chassis. So that's absolutely happening, and there we do need a new set of accelerators. So we can look at, for instance, these new AI accelerated chips that are on the side, separated from the SOCs. Scale AI is one of my favorite ones, where we can see we can do a lot of that. But the problem then, I mean, the technology is there. And the problem for us is then, and like I think it was the second to last panel before us said that an SDV needs to be overpowered. You need to have all the compute and only use half of it. I mean, Gen AI didn't exist 2 years ago. I'm right now designing a platform that should go into production in 5 years. And then the customer wants it to be updated with AI features 5 years after that. So should I now anticipate the AI needs of 10 years? It's almost impossible. And even if I do put those chips in there, when I need them, they're obsolete. Then I can do it for a tenth of the cost for 10 times the capacity. So the upgradability of the new software-defined vehicles and AI systems is going to be our biggest ache.
Interesting. I think going forward, we will have more powerful computers in our car than our home. Okay, so with this, okay, so the next aspect is the safety. So all we are doing, so we cannot forget the safety. So with this, maybe the Anoop. So how you see from BMW, what are the challenges you see the building a safe and then AI-based decision making on roads? So you directly come from the OEM, and then BMW is mainly give the experience directly to the customers, end users. So what are the challenges you see in these aspects? Could you please elaborate on that?
Sure. Thanks, Thiyagarajan. And I think today we've heard a lot about AI and SDVs and bringing all this together really in a safe manner. That's what we are looking at. And the last three words that you mentioned, the decision on the road. We've been doing that, possibly even on our way here. I think whoever has driven down here would always see that you've made multiple decisions at every turn, decisions at every second within your vehicle. And these decisions, many of them are really to keep us safe. Safe for the driver, safe for the passenger, and safe for the people around us, the occupants of the environment. So now that we are looking at safe decisions, there's a time when we are looking at software doing the driving for us, and then the software having to make those decisions on the road. And are these software decisions going to be safe? I think it's been almost a decade and more now that ISO 26262 stepped in and said, okay, we'll try to solve this problem for you. We'll try to define a set of processes and practices that you can do to gather evidence, and also say that and be comfortable enough when a car is out, which is making decisions on its own. And now comes in also the complexity with respect to AI, because now there is more possibilities with respect to AI to even actually do much more within the car, with, as Magnus pointed out, with the all GPUs and DSPs available, there's a lot more that we can do. And this brings in a lot more challenges, and looking at how we could extend the safety standards, the ISO 26262, as well as the sort of standard, and kind of define the processes for AI models itself. When we talk of AI, it's not just the AI models, then it's, the requirements are really the data. And then looking at how the data and the model itself can provide us a safe environment to drive in. So that's where I think these standards are also helping us, and we are also contributing to build them and making the decisions on the road much safer. Thank you.
Hello. Yeah. So as you said, well, the challenges are not only on the drivers, it is for everybody, and then including the environment. Okay. But how do we going to build? Okay. So it needs a lot of validation, testing, all those things. So with this, maybe Shitanshu, so from AWS also you can share your. So what are the roles or importance of the digital twins, and then validation framework is playing a key role here, building the AI models, the testing, and then also how it is reducing the risk, reducing the development cost, time, etc. Can you please touch upon this? Because as you the service provider across multiple OEMs and then tier 1 suppliers, probably you would know the better background on it.
Yeah, very relevant question, and thanks for asking this. So digital twins is actually something very fascinating. It has been there in our ecosystem for a very long time. Started from the mechanical days when the whole design got transformed by using CAD and CAE tools, right? At that time, when it started, we still were building a lot of physical protos and doing all kinds of physical testing, crash tests, and all of those. Over a period of time, we actually corrected those digital twins to be more performant, more as near as the real, so that you reduce the number of physical protos and you are able to simulate, validate most of these testing and validation on cloud, on premises by using various systems, tools in the market. And these have matured over time. Now, as we come to the software-defined era, right, the whole electronic control system design and development, we are taking the same. Right, we are on the same journey. Have to virtualize all the electronic control systems. There are virtual ECUs available for you to build the prototypes, right? And the issue with these the virtual ECUs is that they still need to be tested on the physical setup, right? So you still have to go to a lot of physical tests to be able to come to the actual, optimized algorithm and software stack, right? And this is the bottleneck, right? So the software complexity is increasing, number of ECUs are increasing, you're consolidating the ECUs. In the whole journey, you're actually increasing the number of field tests, right? So when it comes to cost and time of an R&D of any OEM, right? So this still remains a challenge, right? So digital twin in the virtual electronic control system world is still not optimized, right? We are going there. We are taking leaps ahead. But how do we help it? How do we help this whole ecosystem? That's where the cloud comes into play. So by building virtual ECUs and hosting on, for example, an AWS, which will be as near real compared to what you have in the current setup, right? And since these are hosted on certain accelerators provided by AWS. For example, Graviton is a chipset which is having the same instruction set what we find in a physical ECU. You'll be able to actually emulate the entire, the entire ECU while doing the cell testing itself, right? So you reduce your dependency on the hill, you accelerate, you shift left by doing the testing and validation at the cell level itself. You open up the time of the R&D engineers. You free up their time to work on the control system development. At the same time, you are coming up with the product at a faster pace. So that's where I'm saying the revolution is happening. That you're able to shorten the time. You're able to get in the product validated on the cloud itself, and we are seeing this advancements happening everywhere. Magnus was talking about the compute capacity increasing, and we don't know exactly what would be the future demand coming in from the customer, right? How much compute would you have in the vehicle itself, right? That's where the concept of virtual car is also there in the market, where customers are looking at what kind of compute you want to have at the edge versus on the cloud. So for the non-safety critical applications, because OEMs are thinking that if my current SoC will not last for more than 5 years, can I move some of my application to cloud? Can I do my compute on the cloud itself, right? So that's what's happening on the ground. People are thinking about those set of mechanisms to be able to deliver, the future software-defined vehicle. So yeah.
So easy for the digital chain as we think. It's not just a copy paste. It's more than. Well, so yeah, before we move on to the next round on the challenges and then trade-off, I would also like to touch upon the AI personalization. So when we talk about the experience, no experience will come out of without the personalization. So especially the companies like Tier 1, okay. So we are working on the various components. So the personalization will start right from the user experience, the display units, and also the sensors, and also the understanding the environment, and also the giving the experience based on the mood of the driver, based on the situation of the environment. So we are already working on a lot of these aspects to bring the personalization day by day, and also the cost effective, and also the most importantly the safety and then trust, considering in the fact. So these are the kind of the trend already is moving on that. Probably in few years down the line, we may see the car that based on your mood, how well you are starting from home, then your car will get ready, prepared before you enter into that. And at the same time, when you come back to home, after you are tired of working, so the car will make sure that to give the enough regeneration before you enter into the home, so that you can bring the more balance between the work life during this experience. But again, this experience, to get this experience and then to get it more personalized, so there are a lot of challenges and then trade-off, without compromising the safety. So that's a very, very important key. So the next second half of the session, we are going to discuss about these challenges and then trade-off, how we are handling it, what are the way forward, and then what is possible directions. So with this keeping in mind, maybe I'll again start with the Karthiga. So then, what are the trade-off do you see the face between this complexity and as well as the latency? Latency is one of the very key element in our automotive. So the decision has to be made before we think. So what is the trade-off currently we're facing, and then what is the way forward when it comes to the AI model and then latency?
So the question is between model complexity and latency, right? To explain a model complexity in general, a model might, all this deep neural networks that has come in the recent days, like residual net or efficient net, has a number of layers, right? And each layer will have a number of filters, and the number of parameters that goes into each model is also different, right? So that's how you make a model complex. But then the complexity is also needed because that's what gives you accuracy, right? And we've been so focused on getting accuracy in models. But in real time, in a car situation, or even if you have a voice assistant, then you ask a question, right? and it takes 20 seconds to reply back to you. That's where you actually are trading off, for latency and accuracy. Those are instances where latency matters more, even if it's a less accurate answer. So it's like a safety system also, right? Where the latency matters more. Going for a break or accelerating rather than depending on the accuracy of the model. So it's a tough trade-off to do, trade-off accuracy for latency. But then different applications in the car requires different levels of latency and accuracy requirements. So it's how we define the SLA, saying, what is the inference SLA for a particular application in my car, and then stick to it. So saying that, this trade-off is always there. But then there are also ways to overcome this, without losing the accuracy a bit. So there is something called the neural architectural search, right? Where the NAS usually finds you the best deep learning model for a particular situation. So it's like a search technique. So when you do NAS, just not only focus on the software, but also focus on the hardware parts of it. So when you give a query to the NAS to say, give me a best model with the best accuracy possible, don't just focus on the accuracy, but also say that, give me the best latency and with the minimal compute power, that it can run in a car. So hardware-aware NAS techniques can be used. Also, there are model complexity reduction techniques that can be used for inference, right? For training, you can use a bigger model with floating point, and then when you come to inference, you can actually make it into integers, right? That's a technique called quantization. There are also techniques called pruning, where you reduce the model weights that are not needed for the inference, and then there's something called distillation, where you can get a smaller model of the bigger model that you have for training. So making these trade-offs, where you also maintain the acceptable level of accuracy, but also get the latency that you needed. So that's where this can be done. And we can also focus on techniques like on-device fine-tuning, where you do a bit of fine-tuning once after you deploy the model to the car. So with all of that, I think we can still manage an acceptable rate of accuracy and latency is what I would like to say.
To go and then continuously evolve in that.
Yes.
So maybe Sriram, then we talked about, you already briefed about the foundation models. Again, the most important fuel for this foundational model is the data. Okay. So how crucial is the data backbone management and then to bring the more meaningful insights and then decision making? Can you please explain the challenges and also the way forward in this direction?
Sure. So I'm sure all of you would have heard the cliched statement, data is the new oil, right? So I thought I will not use that, but because there is so much Okay, the rain stopped, so did my talk, right? So because there was so much rain, I was thinking of this rhyme when you think of an ocean, right? Water, water everywhere, but not a drop to drink. Similarly, I hope car makers do not see a car and say data, data everywhere, not a bite to use, right? So that's one of the major challenges. Now, linking models and data, right? I'm sure many of you would have listened to Andrej Karpathy's speech in the recent Y Combinator session where he says, the evolution of software, right? Software is changing again. And he talks about software 3.2, where we move from, not just neural networks, but we move to LLM-based software writing. So now when you have such type of software in your car, data becomes of paramount importance. Right now, again, two dimensions here. One is data aggregation itself. How do you collect data? You need to have the right data frameworks. I'm sure each OEM or IO1 have their own strategy. For example, is data mesh architecture an important mechanism to capture data? Data loops, how important it is, right? So the other dimension is it's not just about data, but how do you create this fast loop between the cloud and the car? That matters more. So in a sense, how fast can I train a model and put it into production? How fast am I able to find an issue, fix it, and then put it back into a car? Or how fast am I able to read data, put it into a cloud, train a model, and push it back into the car? So when such things matter more, I think practices like what we call as CD4ML will become increasingly significant because then it also brings data scientists into your loop. And it is also a cultural advantage because you don't throw one problem over your cubicle to the other, but you bring your data scientists, you bring your AI engineers, you bring your domain specialists, your infra engineers, all of them together and solve this for faster time to market, which is what all automakers want. So that's how I think the data aggregation framework and the ability to manage data at fast speed will become crucially important.
Thank you, Sriram, and thanks for bringing this importance of the data. Then maybe Magnus, you can just say that changing the software is easy, but the hardware is not so easy. Can you briefly tell or explain, okay, what kind of the new hardware going to shake up in this whole SDV domain going forward?
All right, of course. My old boss used to say that this is the perfect time to be an engineer, and that's kind of true. I think you're not through one disruption before the next one hits you in the face. So, well, what I mean, Sitanshi already said the first one, right? How much, if we can't build an SDV that is upgradable for 10 years, right? Can we then instead move compute to the cloud? I don't think we have the connectivity yet to able to move connectivity there or move compute there, but it will happen, I'm pretty sure. And then I heard a question in the morning, right? So chiplet technology, that would be a cheaper way to be able to configure and upgrade our HPCs. If we can move out the accelerators, the GPUs, the most expensive chips, right? And then we can instead of changing out the $1,000 HPC, we can just exchange one chiplet. So far, I'm not so sure how many of you have seen a truck workshop that has a clean room and workers with white gloves and so on. But which is kind of needed at this point to be able to change chiplets in production. But that might come very soon. Another shift that's coming that I'm super excited about. I don't know how to handle it really, and I don't think it's going to come on board very soon. But quantum technology. I mean, we had the OTA people up before us, right? So, not that we're going to move quantum into the trucks very soon, but being quantum safe in the trucks is going to be an interesting challenge. And then the last one, as I said before, heat is a massive problem for us. So if we can come to optic or photonic compute, that could help us quite a lot. So good things are coming.
I think it's much more bigger than we imagine. I think we need a separate research on hardware. So Anoop, you already explained the safe AI. Can you also touch upon how we are during these challenges in this AI, how we are going to ensure that traceability and then generatability? So with the Gen AI, all is more important. So how this is being handled?
Thiyagarajan already for answering it for me, but also, I mean, number of technologies that are upcoming, and how are we going to compute on the cloud with a good connectivity? Maybe the T systems can help us here. But jokes apart, I mean, let's just imagine we are driving on the road and there's a car right next to us which is autonomously driven. How safe would we feel even though we are not in that car? So that's the place where the explainability also implies, as in we are able to really say what the car is going to do and also feel safe inside the car as well as on the for the other participants in the traffic. So coming to the inside of the car, there are different levels of or different technologies that are helping us, maybe with VLMs and so on. And if you look at some of our cars, it's really the driver and the car become one, where you're able to really talk to the car and the car is able to communicate to you in a way that you completely understand each other. So coming to that level, also with an AI software is quite an interesting topic, especially with the kind of explainability that we can obtain from AI models. Again, I would switch back to the ISO 8800, where we are trying to also answer how an incident could also be traced back as much as possible and also look at the data the architecture of the software architecture with the AI in between, as well as looking at how the AI model behaves during the operation. With all these three coming together, are we able to explain, reason, and keep our surroundings safe? That's something that we are also keenly trying to answer and use AI to its fullest. Thanks, Ted.
So with this, definitely it will more lead the road, the Gen AI topics. So, but all these may be the Sriram, so how you see what are the limitations in this simulation models or the platform, which you already touched upon the complexity of the digital twin. But what are the challenges you are seeing with this limitation?
Hello. So yeah, so there are challenges. I mean, we have the best state-of-the-art tools, the softwares where you can design your virtual control system, you can test, validate. But if you really understand, I mean, who are the users behind it, right? We're talking about fresh graduates coming out of the college, people with 3 to 5 years of experience actually using these tools on a day-to-day basis, right? And then Amazon, we have a philosophy of working customer backwards, right? Understand the customer and design it for them. So tools are complex. It takes time for them to understand, develop, use it. So that's where we've seen AI coming into handy, right? How do you use AI and generative AI to actually help the learning curve be more, faster and more steeper, right? And that's where most of these tools are trying to come up with assistance where anybody who's using any kind of a simulation or building a model, right? An assistant who can help them guide through the entire process, be it developing an adaptive AutoSAR application or even working on any kind of a application which is on very different kind of a script, right? Not C, not maybe a different kind of language comes into as a new concept, right? So how do you help these people gear up, speed up, and work towards it? So that's where the AI comes. The generative AI actually helps them out. And we have seen a lot many OEMs are also adopting it in their development journey, right? For example, there are few customers in India who are at working with cloud services. Can design some of these applications by giving some command prompts, right? And with these prompts, if it is if you give the right prompt, you'll be able to come up with an application or a software code which is really, I would say, 70 to 80% accurate. It reads to the foundations of AutoSAR, foundations of all the different compliances, MISRA, and it will give you a code which is something which is really almost 80% there. Need some kind of a human supervision to be able to correct it, rectify it, and then obviously use some of the tools to do the simulation exercises. Right. So this is where we are seeing the whole industry is moving to. So enabling, making the people capable to use some of these tools is a critical challenge. No wonder, I mean, these tools are all, I mean, the best in the world, but then obviously the usage, the applicability becomes a critical, point to address.
Yes. So yeah, with this note, we are come to end of this session. So definitely with the leaders and an expert, we can take a clear message that the convergence of AI and then data and autonomy will drive the next decade of future mobility. Because going forward, the vehicle will not be the only for drive. It will learn, evolve. It will learn, adapt, and then evolve. So definitely, we have to ensure the safety, trust, all those things, and then we need a more responsible development, collaboration across the ecosystems like data, hardware, Gen AI, etc., to bring more and more human-centric experience. So that's how we see the immediate, very next future of SDV. So with this note, I express my very sincere thankful to all the panelists for sharing your STEAM experience. So with this note, I open to the audience to any questions. Yes.
Hello, this is Hallikeri, Director of Architect Solutions, Bangalore. We have been working on autonomous vehicle for data validations, data labeling, and KPI test and validation. So, question to Madam. See, while annotating the data to train algorithm, what happens? We have seen automation 60 first shot 20%, another was shot 40%, 50%. We have achieved till 60 to 70% for automation for only 2D data. First, for LiDAR data, we are not able to achieve automation. So, is there any possibility we can only achieve for sequential data? We can achieve for 20%, and non-sequential it is very tough because we have to do check frame by. Is there any possibility to automate at least 60 to 70% LiDAR data?
I assume when you mean by automation, you mean the simulated data, right? That comes out of a tool like Carla or something,
Yes.
right?
Yes.
Okay. So you mean the number of scenarios that you can create so that you get the LiDAR data out of the car?
Yes.
Is that what you mean?
Yes, yes. Basically, what we have seen is we have see when you are doing annotation for 2D. First, we will do manual annotation. We do again. We'll train the data. We'll train that data. So we'll do 100% manually. Second phase, third phase, fourth phase. Definitely, my algorithm will improve. Definitely, by more automation, I can do it. So human errors, human engineers are not required. Like only QC people are required when my algorithm is robust. So automatically tool will take care and mark all the objects and detection everything. So it is happening only in 2D, but it is not possible in sequential data for LiDAR 3D.
Okay. I'm really not sure about the 2D, 3D parts of it, but then something like a world model, I think companies do follow. I'm really not sure what is the maturity of the World Foundation model that's currently,
Yes,
but that's
yes.
supposed to be able to simulate all the real-time driving scenario, and so that you don't have to, go on driving real time and then gather data. But yeah, 2D and 3D, I'm really not sure. Yeah.
Okay, okay, no problem. Thank you. Thank you.
On this, so just to add on what Karthiga said, so the LiDAR models, generally the data is more costlier compared to the radar and camera. So yeah, so
It's a 3D point cloud.
so it may take even more time because
Then
always the AI is the learn, adapt, and then evolve. So
yes, yes.
unfortunately, the LiDAR is so costly, so the
Yes.
data is not available to us. Maybe over the longer run, we'll have more data.
Yes, yes.
Probably like Shritam explained, the digital twins will help here. So
And-
bringing more kind of the virtual data, the simulated data, we have to rely on that. But going forward, and more LiDAR sensor is used, the data is generated. Probably that could be possible.
Yes, yes. But we have been trying, but we are not able to achieve it. But automation, but because of point cloud and all, it is a little challenging, as you said. Yeah. Yeah. Thank you. Thank you.
So if no more question, and then I thank everyone for your session. Thank you all.